Consider the isosceles triangle KLM in which the length of K to L is 20 centimeters. I'm going to label this as I read it. The length of L to M is also 20 centimeters, and the length from K to M is 30 centimeters. If you forget what an isosceles triangle is, it's a triangle that has two equal sides, and in this case it would be these two, and two equal angles, that would be M and K. So it's symmetrical. Why can we not use SOHCAHTOA with this triangle to determine the measure of KLM? Now some of you might have been tempted to do that. And if you were tempted to do that, the first question I'd ask you is, where is the hypotenuse of this triangle? There isn't one, right? We need a 90-degree angle to have a hypotenuse. So SOHCAHTOA or trig functions or trig ratios only work on right triangles. And that's what SOHCAHTOA is. It explains our trig ratios. Trig ratios only work on right triangles. And when I say right, I mean triangles with a 90-degree angle in them. An isosceles triangle does not have a 90-degree angle in it. So determine to the nearest degree the measure of angle KLM. So what they're looking for is the measure of angle L, really, by splitting this triangle into two congruent triangles. Congruent means equivalent, they're the same size, right? Because an isosceles triangle is symmetrical, what we're able to do is split it in half, just like I have, and what happens to that base length, if it was 30, now it's 15 and 15. I already mentioned that angle K and angle M would be the same in each of these triangles. But what we've done by putting a line straight up and down the middle is we've created a right angle in both cases. So let's look at one of these. Now what I'm going to do is I'm just going to label, let's pick another color here. I'm going to pick another letter. So we have KLM, let's call this N here. Just so you can see, we'll talk about triangle NLM first. Okay, so that's N to L to M, this triangle where I put a 90-degree angle in. And we want to determine that top angle. Okay, let's call it X. So in case that picture's unclear, I'm going to redraw it down at the bottom here. So I've got L, N, and M. I know this is 15, and this is 20. There's my 90, and there's my unknown. Let's start by solving for that unknown. So which trig ratio, which I can use now because of the 90 degrees, uses opposite and hypotenuse? So we'll use sine. Sine of this unknown angle would be equivalent to 15 centimeters divided by 20 centimeters. Just like in the previous two examples, don't be tempted to cross multiply here. There is no unknown on the right-hand side of this equation. We know the numerator, we know the denominator, so don't split them up. Instead, we'll go second function sine to determine the angle of 15 over 20. Now, did they ask, yeah, to the nearest degree? I'm going to leave it just like this. I'll save my rounding for the final step. So 48.59 degrees. So X is equal to 48.59 degrees. Now the problem is they didn't ask for angle X. What they wanted was angle KLM. They want the whole top part. Now the nice thing about isosceles triangles is they are symmetrical. So when I cut it in half, I have two congruent triangles, or two triangles that have the same measure of angles and the same side lengths. So if I know what this side is, then that top angle on the other side would be the same. That would be in triangle KNL. Triangle KNL, that top angle is 48.59 degrees as well. So to get the full measure of this isosceles triangle, I can just take what I found and multiply it by 2. So take what you found, which was half of the angle they were looking for, and multiply by 2 so that you've got the full angle that they're looking for. And now they did say to answer to the nearest degree, so I saved my rounding for the last step, which is a good idea, otherwise your answer can be off. So I'm going to say angle KLM is equal to 97 degrees.